So one of the things that we're going to be doing here is we're going to be taking a look at identifying the different parts of the triangles. Now, in this picture that you put into your notes, the big thing is noticing that I drew in this angle. These particular names are based on it going from this particular angle. Of course, the triangles, they can turn any which way, but these relationships are not changing. From that angle that's been drawn in, the opposite, the adjacent, and the hypotenuse are still all the same pieces. So none of that's changing as I turn this triangle around. So it's always all about just which angle are we actually going from. With that in mind, here's an example problem where we just have a bunch of named pieces. Now, the first thing that we need to know is which angle we're going from. Notice in this case it actually tells us which angle we're going from. It tells us that this is from angle A here. So, I'm going from this angle. And I want to identify which side is the opposite, the adjacent, and the hypotenuse. Well, the opposite is the side that we aren't touching with our angle. A way you can even think about it is put your finger at the angle. Which side are you not touching if you put your finger at angle A?
You're not touching.
It's got to be this side over here. This is the opposite. So the opposite of angle A then is side A. By the way, that'll tend to be a trend. If they follow normal naming conventions, the lowercase letter will be opposite the capital letter. And lowercase letters represent sides and capital letters represent angles. But that's detail. All right, the adjacent. The adjacent is one of these other two sides. Now, if you have trouble telling which one's the adjacent right now, skip over it for a moment. Go straight to the hypotenuse. Which side is the hypotenuse? Well, again, you could think of it as opposite of the right angle. That's the way our notes say. So if I put my finger at the right angle, which side am I not touching?
B.
It's got to be B. And so that is my hypotenuse. I can also know the hypotenuse by it being whichever side is longest. And you notice there the longest side is B. So if you're having trouble with the adjacent, now you can know the adjacent though. The adjacent has to be C, because that's the only other side length that we haven't named yet.
Wait, what?
So now let's repeat the same process. In this case, we're looking at the same picture, but in this case, we're going from angle C. All right, so first up, I'm going from C. It's a good idea to draw it in or kind of put your finger on that angle. And then the opposite is the one that's on the opposite side of the triangle, the one that we're not touching. That's got to be little c here. Notice that is a lowercase c. Right, the adjacent and the hypotenuse. I will often identify the hypotenuse first because the hypotenuse is opposite the right angle, otherwise known as the longest side. That is B, meaning my adjacent here is A. Now I gave you the same drawing for this one as I did in the last problem, except that I gave us a different angle to go from. Notice what didn't change. The hypotenuse didn't change. Because the hypotenuse, the side that's opposite of the right angle, it still was opposite that right angle. But when I switched which angle I was going from, the opposite and the adjacent, those two ended up switching. So the other piece we're taking a look at here is measuring angles on the circle. This is the basic idea behind how we measure angles on a circle. It always goes, we're measuring from the right horizontal, so from this line right here, we measure then counterclockwise. So it's how far we're going around from there. And that's going to be true no matter how far around the circle we're going. We're still starting at the right horizontal, and then just saying how far around are we going counterclockwise. All right, so then I want to help visualize where a few of these angles would be on a circle itself. So here we have the angle 90 degrees. Which way would 90 degrees be going? Where would I need to draw that in to make 90 degrees? So 90 degrees, remember, is a right angle. So that's like squaring it off. So you notice 90 degrees then would be going straight up. Because again, I'm starting from going straight right, and I'm going counterclockwise from there. So it's saying that that angle there is 90 degrees. Okay, then where would 270 degrees be? Well, 270 degrees now, I know that I need to start from this line straight right and then go counterclockwise from there. Well, this is 90 degrees for that part. If I keep going, that'd be another 90 degrees. So what's 90 plus 90? Yep, 180. So that'd take me around to a total of 180. What if I went around another 90 degrees past that?
270.
180 plus 90, yes, is 270. And so that's what I was looking for. So then 270 degrees is this angle right here. It's going straight down. All right. Now what about 135 degrees? Where would that be? All right, so again, thinking about how far around those increments are, I know that this would be 90 degrees here, just going straight to that, and it'd be 180 to get straight left, which is too far. That's past the 135. Okay, so how far past 90 is 135 degrees?
In the middle.
And technically speaking, I could do 135 minus 90 to find that out. 135 minus 90 equals 45. So it means it's 45 degrees past 90, which, yes, is exactly halfway between 90 and 180. All right, what about 190 degrees? Where would 190 degrees be? Now you'll notice that with this problem, as you start thinking about it, one of the great things to know is those 90 degree increments. So like I look at this and I instantly think, well, 180 is pretty close to that. And I know that's straight to the left. Well, it's got to be another 10 degrees past that. So I'm going another 10 degrees counterclockwise. It's not very far. It's going to be right about there. So that angle then is about 190 degrees. All right, last one. Where is 312 degrees going to be? And as you look at it, again, knowing those 90 degree increments is going to be very useful.
What's the
Because
last one?
I know that I can get straight down at 270 degrees. But if I continued going all the way around, I'd get up to 360, because 360 degrees is a whole circle. So I know it's got to be between those two someplace. Well, I want to know exactly how far. So let's do 312 minus that 270. If I do that, I get 42 degrees.
It's in the middle again.
So it tells me it's 42 degrees further on from 270. So it's close to being in the middle, but not quite there. So we're going to put it right around there. We're estimating at the moment, but it should be right around there. That would be our total angle of 312 degrees.